Good morning, Year 11s. This is the PowerPoint I promised you with regards to revising electrolysis. I'm going to try and get everything done really quickly, but do replay, do whatever you need to do in order to get this into your head. If you're coming to the revision lesson on Friday, we'll also look at it then. Here we go. So electrolysis then, we're going to start off really simple with the electrolysis of a binary compound. So the first thing you need to understand, and it's absolutely crucial, that you understand that metals form positive ions and non-metals form negative ions. If you get this wrong, the entire answer will be wrong because you will get them the wrong way around. Okay? Metals are positive, negative, non-metals. So ionic compounds, and that's important, we're talking about ionic compounds, are made of metals and non-metals, so positives and negatives. That's going to be crucial. We can use this characteristic of a positive and a negative to rip apart the ionic compound using electricity. So you can imagine this is going to be extremely difficult in real life. We're going to need a lot of energy, and that energy is coming from the electricity. And we call this process electrolysis. Electrolysis literally means breaking down using electricity. So we are breaking down the compound back into its elemental form. We're looking at a binary compound. I don't think this will come up, but I just wanted to give you a heads up and start somewhere easy. Binary meaning something that has two parts. So the basics. You should know electrical circuits have a positive and a negative element to them. So battery, positive side, power packs, positive port, negative port. So there you go, that's my representation of those two sides, the positive electrode and the negative electrode. In electrolysis, it might look something like this. The colour of the wire is irrelevant. One of them is positive and one of them is negative. Okay, so electrical circuits have positive and negative, and so do ionic compounds. Now, ionic compounds are held together with a strong electrostatic attraction. We know that. That's a very strong bond. It's going to take a lot of energy to overcome it. You turn on a little bit of electricity, not much is going to happen. To give it enough energy, though, opposites attract. As always in science, there you go. The positive, in this case sodium, goes to the negative electrode, and the negative chlorine, so that'll be a chlorine gas, goes to the positive electrode. Opposites attract. If you are answering a question on electrolysis and you are not talking about positives going to negatives and negatives going to positives, and the phrase opposites attract in some way, then you are not answering the question correctly. Okay, so the next point you need to recognise, here is a solid ionic compound. You can see it's solid, look, they're together, and if you look at each individual one, there is no overall charge for each compound. So I'm looking at that top NaCl there. I've got one positive, one negative, so overall they cancel each other out. So an ionic compound has no electrical charge. And as we know, no electrical charge or no free electrons, or in this case free ions, we are not going to be able to conduct electricity. So ionic compounds that are solid do not conduct electricity. That's important. You will be asked at some point, why do solid ionic compounds not conduct electricity? And the answer is they do not have any free ions. Notice ions, not electrons. Okay, that is the one difference here from where we normally talk about. Now, if I melt this compound, or if I dissolve this compound, the ions, it's a weird one, guys, it's A-level, but the ions separate. And even though it's still sodium chloride, they are able to act separately. Well, now I have charged ions, ions that are free to move and carry an electrical charge. So you need to understand this fact. I can't remember if it's on this test, I wouldn't tell you if it was, but you are often asked why it has to be liquid in order for electrolysis to work. And it's this idea that they've got free or delocalized ions, not electrons, in order to carry the electrical charge. Be careful. So here are some questions. You can pause the video, guys, and have a go if you want. I am not going to talk about them. I'm just going to, if you want to pause the video, pause it now. And then here are the answers that you would, something like this anyway. Okay, moving on. Okay, so how is that going to look in an exam? Well, you're going to be given the name of a compound, and you would need to recognise that compound contains a metal and a non-metal. Which one's which? Well, you should know the metal is always first. And if you weren't sure, hopefully you would look at your periodic table. You would recognise that sodium is on the left-hand side of the periodic table and therefore a metal. And therefore the metal is positive. You can see where I'm going with this, and therefore it will be attracted to the negative electrode. It's a very simple process, but as I said earlier, if you get those the wrong way around, you can answer the entire question wrong. So chlorine is a non-metal, so it's negative, and therefore it will be attracted to the positive electrode. And of course, why is all that happening? Our golden rule of electrolysis, because opposites attract. This works for any ionic compound, so I could replace that with lithium fluoride or magnesium oxide. Is there any more? Iron sulfide. It's all the same idea. One is a metal and one is a non-metal. If you don't know where to start on a question, start there. Identify the metal, say it's positive, talk about opposites attracting, and say where it's going to be attracted to. Okay, let's take this a step further when we've got water involved. Okay, so we looked at this very briefly before. So you'll often be given this something like this diagram on the right-hand side here. What do you need to know? So you need to know if you're preparing a practical, obviously it needs to be connected up to the power pack. And you need to recognise that these electrodes, that is the rods sticking in, are made of graphite. Now graphite you should recognise is a type of carbon. And it's an unusual type of carbon in that the layers enable there to be free, and that's really confusing now, free electrons to carry the electrical charge, and that is why we use them. So even though they're a non-metal, they conduct electricity. Well, why do we use this non-metal? Well, they are inert, so they are unreactive. They're not going to get involved in this reaction. They are simply allowing the electricity to pass it through into the liquid, and they are cheap, so they do decompose eventually, but they're easy to replace. Okay, I cannot understate the relevance or the importance of this diagram. You're going to need to know how to label it. This electrode here that is connected to the negative side of the battery or to the negative side of the power pack is the cathode. The positive electrode is known as the anode. And the liquid is not water, it's an ionic compound that is either molten or dissolved, and it is called electrolyte. Now, this is where you're going to get confused. The positive ions, because opposites attract, the positive ions that are attracted to the negative cathode are called cations. So they are called cations because they are attracted to the cathode. And on the other side, the anions are attracted to the positive anode. So they're negative. You can see here that this is not necessarily a complicated idea, but it's so easy to get muddled up. Let me see if I can give you some tricks to help you. So Miss Syed always teaches to panic, okay? P-A-N-I-C. Positive anode, negative is cathode. And that's brilliant. Traditionally, I obviously went round the houses with my explanation. I have a really grumpy Auntie Kath. She's the eldest of my mum's 8 siblings. She's really grumpy, and so in my head I've always remembered that the negative is cathode. I also randomly have a really good friend in her 90s now, who's a lovely positive woman called Anne, and that makes my life very, very easy. It doesn't matter how you remember this, just remember something. So let's have a look here again. Yes. Be careful here, guys. You'll notice here that I have flipped the battery. Okay, that is a classic move from the exam board. They will ask you to label the diagram, but they will flip the battery or whatever the picture is to make sure that you recognise that that is now the cathode and that is now the anode. That's now a cation. Yes. It's a little happy cat because it's positive. I don't know if that's going to help you guys, but whatever it takes. And the ions are over here. And of course the electrolyte. It could be like this. Okay, so this diagram looks very, very different, but it's exactly the same principle. I've lost my button, where is it gone? So I hear, again, you're looking at that battery. The negative is the cathode, the positive is the anode. You'd have anions over here, you'd have cations over here, and that's my happy cat, and it's already labelled with the electrolyte. So don't be off-put. That's when we're trying to collect gases. Don't be off-put if the diagram changes. You're just looking for those clues to make life easier for yourself. That's how they trip you up. You've got to be aware of it. So I looked at this previously. Realistically, on a higher paper, they are not going to ask you about a binary compound where you've only got the one positive and the one negative. They're going to make it more complex because they're going to introduce water. Okay, so water is a rule breaker. You should recognise from when we did acids and alkalis, water is made of a H plus and an OH minus ion. So even though they're both non-metals, hydrogen is the rule breaker, it forms a positive ion, and that makes things a little bit more complicated. So here you can see I've got my iron sulfide, but this time I've got the word solution. Whenever you see the word solution, you're going to think water. So let's get rid of the easy bits first. Got iron going to the negative electrode. I'm hoping I don't have to explain that because I'm not. I've got sulfur going to the positive electrode, and again, I'm hoping I'm not needing to go into that. Now let's look at this word solution. You need to recognise that word solution means water, and therefore you would have the H plus. Where's that going to go? Well, it's a positive, it's going to go to the negative, so the cathode, and it's got the OH minus. Where's that going to go? It's going to go to the positive electrode or the anode. And you'd need to recognise all that from the word solution. Now, they might not use the word solution. They might say aqueous iron sulfide. It means water, aqua. Or they might simply give you the brackets there, AQ in brackets. Again, aqueous means water. So aqueous iron sulfide or iron sulfide solution, it means you are in the presence of water. It's dissolved rather than molten, and you've got to recognise that, otherwise you're going to miss out half that question. Now, how can you improve this answer? It's pretty basic. Well, you could label the electrolyte, the liquid. You could label the cathode. You could talk about the anode. You could talk about the cations. You could talk about the anions. So you can take this question as far as you can. And I guess it's just taking it literally as far as you can, and not worrying if you forget about the electrolyte. Have you had a go at which one's the cathode? So let's look at how you would realistically approach that question in an exam. So it says, how do you electrolyse lithium fluoride solution? How do you use electrolysis to separate it? Well, I always say if you're struggling to start somewhere, start at the cathode. I don't know why I always start, I don't know. I always start the cathode. I know that the cathode is negative. Boom, right, easy, mark. Okay, that means I'm going to attract the opposite. So I'm going to attract the positive, okay? What's the positive? Lithium. And because I have a solution, I'm going to attract the hydrogen. Okay, nice. Now what about the anode? Well, that's positive. Attract the opposite, negative. What's that going to be? That's the fluorine, and that's the hydroxide there, the OH minus. So you can see there how I've broken it down, and if I'm not sure, I'm starting the cathode. Start where I know. Okay, I suggest you pause the video and have a go at this for yourself, recognising that there is AQ there, meaning water. Okay, I'm going to quickly break this down for you if you had a go at that. So I'm going to start the cathode, which is negative. I'm going to attract the opposite. So that's the positive metal, which is magnesium. And I've got AQ, so I also know I've got H plus there. At the anode, that's positive. I'm going to attract the opposite, which is negative. That's going to be my oxygen. Notice it's oxygen, not oxide, guys. And also the hydroxide from the water. Okay, pause the video if you want to have a go at this yourself. Right, so we've got starting the cathode, which is negative, attract the opposite, positive metal. So I'm looking at lead. I'm recognising I've got the word aqueous, which means I've got water, and so I'll have the hydrogen ion as well. At the anode is positive, attract the opposite, opposites attract, so I've got the negative, and that's going to be the bromine, and of course the hydroxide from the water. Notice there's a lot of repetition, guys. You might have to write it. I would write it out because you'd be surprised where you get the marks from.